In this video, I'd like to do some examples of evaluating inverse trigonometric functions. And the first recommendation before we get into anything is that these work exactly the same as original trigonometric functions. Everything is just backwards. So if you've been understanding how we evaluate sine and cosine, I'm not trying to confuse you because it really is the same. It's just everything becomes backwards, and this can really be a mind trip because all the locations of where things normally go seems different. Um, but that's kind of the main thing I wanted to mention, as well as they're not reciprocals as I said in the previous video. And we will get into some applications here in a second as well. But let's move to the packet. Where I wanted to let's start with a few examples in the unit circle. So one thing we know is, say for example, what if I wanted to know what's the sine of pi over 4? Well, what sine does, right, is I take the input, which is the position, pi over 4, and sine always returns y, root 2 over 2. So cool, that's how it works in general. But basically, if we're trying to use an inverse function, what will happen is the input and the output will be reversed. So since I already know this correlation, let's say I wanted to take the arcsine of root 2 over 2, that should come back and return the input, which was pi over 4, because that's the whole purpose of an inverse function. Whoops, I need to fix my tablet because that is way too big. But this should return pi over 4. And basically what we're doing is we're switching the input and output. Now, it's actually not quite this simple always. It really depends on where you're at, because this will always work in quadrant 1 because that's where the inverse functions were defined. But if you're outside of quadrant 1, things can get a little confusing. So another example is, well, cosine of 2 pi over 3, 2 pi over 3 is here, cosine returns x, that's equal to minus 1/2. Well, if I invert that, cosine of minus 1/2 should be 2 pi over 3. Again, technically, there are a lot of cases where it will not work exactly like this, but that's the general idea. Inverse functions will take your current location. Arcsine will take y and return t. Arccosine will take x and return t. And those functions have their own particular purpose. And these are super helpful with solving equations and solving triangles, and we'll see how we use these very soon. And ultimately, you can still use your calculator to figure all this out, but that's the general idea. Let's say, for example, we wanted to solve a few more. Like, what about the arccosine of 1? What does that mean? So what my recommendation is, start by thinking about, well, what is the input? What is the output? Like, what am I looking for? What does this mean? Arccosine's input is always x, and its output should return where am I at? Like, basically, input should be the fractions, output should be the pi's. Usually, you plug in the pi thing in, and you get out the fraction thing, but it's just backwards. So here I'm looking at, well, where is x1? So I would just go to my unit circle and look at the point at the x. So I'm looking at the first point, and where is x1? Well, that's, of course, at the initial point. That's where x is 1. And so what it will return is, well, what's the associated t value? So it will return, it will, again, technically you could answer in either radians or degrees, because either one is correct. But it will then return your location. But which answer will it give me? I mean, we don't know. But notice how at this location, what I have is two answers, 0 and 2 pi. Another thing you might wonder is, well, which is the answer? Is it both or what? But that's kind of going back to the original domain and range, which is why I was going on and on about that before. But basically, the inverse functions will always give you an answer within their associated range by definition. So with arccosine, it's always going to give you an answer in the interval of 0 to pi. Or I think a helpful way to remember that is the answer it's going to give me are always going to be on the top half of the unit circle, because this is from 0 to pi in terms of t values. So if I'm looking for where is cosine equal to x, it's always going to be in that particular domain, because that was the little chunk of the curve that we cut off in order for it to actually work properly. So my point is, it's going to give us the answer 0, not 2 pi, because it's only, like, a function must give one answer, it can't have two answers, and it's got to be in that interval, and 0 is. So basically, that's our answer here. Going back to, well, what is the arccosine of 1? It should be 0. That's pretty easy. And notice that that's in the same way, the cosine of 0 is 1. It's just the reverse of that. We're swapping x and y, which inverts our function, switches our function machine to revert for predictability. Also, your calculator can do inverse functions, which I strongly recommend you use to check yourself, because this is super easy to get mixed up. Even I get mixed up from time to time with inverses, because it's all the same, just backwards. Anyways, but right above sine, cosine, and tangent are the inverse functions. Those are not reciprocal functions. Just I've said it before, but I can't say it too many times. It's very easy to make that mistake. But say I want to do the arccosine of 1. There we go. And it will return 0. And I can check myself out. Also, another thing to mention, in a previous video I talked about degree versus radian mode. The inverse functions work in either mode too. So the answers you're going to get are going to be dependent on the mode you're in. And actually, I recommend setting your calculator in degree mode as well for using these, but because it actually makes it a little bit more obvious where you're at. Let's do one more without a calculator, and we'll use it to check, and I'll try to reiterate the importance of what I'm discussing. But let's do one more. For example, let's say we wanted to do the arcsine of root 3 over 2. Again, what I would focus on is, well, what's the input, what's the output? Since it's a sine function, sine of t is always y, and it's reversed now. Arcsine of y should reproduce what t would be. And basically, on your packet, I put those fundamental properties to help you imagine, well, what gets plugged in? What is this type of number? And all that helps us know is, well, where am I going to look? On the unit circle, I then want to look for where is y root 3 over 2. And also, like before, sometimes you get more than one choice. Like on the unit circle now, if we look for that, notice that actually y is root 3 over 2 in 2 different locations. So what an inverse function is going to try to do is tell me, well, where am I at? Here's the problem. Which is the correct answer? Which is the correct position? Because what I have is, well, t for root 3 over 2 is pi over 3, but over here it's 2 pi over 3. Are both correct? And so it's a very context-based thing, because actually both of these answers technically are correct in an equation, but when it comes to inverse trig functions, there's only ever one right answer because it's a function. Functions have to have one answer. They have to be predictable, as is the nature of functions in general. And also, if you're ever stuck with this question, I don't know which is the right answer, that's the whole point of knowing the range. Because if I go to the arcsine function, it says its range of the arcsine is from negative pi over 2 to pi over 2. Which if we think about the unit circle, negative pi over 2 is down here and pi over 2 is up here. So where the arcsine is defined, it's actually different than arccosine, which is also easy to get mixed up. But basically, it's only going to be this answer. This is going to be the correct position because that's where the arcsine is defined. I'm kind of ignoring the left-hand side. I'm only working with the right-hand side, because it's not one-to-one. So my point is the correct answer is the answer in that range from negative pi over 2 to pi over 2, which would be, again, I'm inputting y, I'm getting back t, so this answer should be pi over 3. And we could check ourselves with a calculator in radian mode. Arcsine of root 3 over 2. Excuse me. Gives me 1.04. One thing with the calculator is if you're trying to do these things, you might not know what that is. And a lot of times I'm going to ask you to do it exactly. So if you just tell me this answer, that's not what I'm looking for. I'm looking for the exact right answer. But there's a trick I wanted to show you that you can outsmart me when I'm asking you for an exact answer. But what I wanted to show you is that should hopefully be pi over 3 perfect. So notice I've gotten the correct answer. I can use my calculator to check myself. But if you use degree mode, I recommend that for the average person because most people aren't very good with radian modes and the understanding of what that means. In degree mode is much easier to understand for the average person. So if I do the arcsine of root 3 over 2 and I'm in degree mode, notice what it gives me is 60 degrees. That's, of course, the same position as pi over 3. It's an equal measurement. But, I can tell exactly where that's at. It's in quadrant 1. It's right there. And it makes a lot more sense how this is working. And now another thing you might be wondering is, so what's the right answer? Is it pi over 3 or is it 60 degrees? Well, remember, those are equal, just a different type of answer. So you could use either answer that you want. But as I said before, radians is typically what we're looking for because it's a better type of answer. It doesn't have units built within it. And there are sometimes problems when you use units in certain formulas, which we'll see more when we get into applications of this later. In the next video, I'll show you how you can use them to solve equations, and we'll be continuing to use inverse functions all through chapter 4 and 5. And even if you're not feeling like you're quite understanding this, or you're just feeling confused, which is very common here, it's not that big of a deal. I'll teach you how to use it even if it's not all the little things aren't understanding, but hopefully that helps with the basics. See you in the next video.